Hey, happy Monday, everybody. Welcome back to another episode in this series on how to build secure networks. Today's topic is really exciting for me because it's actually one of my more favorite topics to talk about in general. A lot of the previous stuff that we talked about, isn't necessarily all that fun or interesting, but is more just kind of basic fundamental things that's good to do, such as documentation and things like that. And I get it. It's hard to get pumped up for something like that. But today's topic is going to be dealing with network access controls. And that is something that, to me, there's so many different ways that you can do it, and it's something that a lot of organizations don't necessarily utilize in all that great of a manner. So I think we should talk about it, talk about how we can do things a little bit better and kind of some different perspectives that you might not have thought about before on ways to go about implementing network access controls. So let us hop over into the checklist that we've been following along. We've been using this kind of as our baseline to provide some tips from. And honestly, when looking at the network infrastructure policy STIG, there isn't much in here as far as network access control goes. So don't worry about that. We're going to talk about this one thing in here, and then I'm going to dive off into the deep end of a whole bunch of other stuff. So this is just a jumping off point into some other discussions that I think are really, really important. So within the STIG here itself, they are talking about ensuring that you have a deny by default security posture, and that must be implemented for traffic entering or leaving the enclave. So what does that mean? Pretty much, they want to make sure that you are blocking all traffic coming in and out of your environment. So you probably have some type of firewall that sits between your organization and the internet. And the type of traffic that you're going to be blocking from that could be to and from the internet. It could be to other partner organizations via different types of tunneling mechanisms like IPsec. Could also be to your different types of cloud environments as well. So if that's the case, then network access control should be pretty simple, because network devices, whenever you implement some type of security policy or access control, is going to be deny by default by default. So, organizations should have this, really locked down. It should be really easy. Sadly, that is not the case, because what ends up happening is all it takes is you creating another rule. The next rule goes on top of that and is read first. And the first thing an organization might do is allow all traffic out to the internet. We talk about different instances of things that have come up recently, such as like the SolarWinds hack. That's a perfect example of an organization putting in access control rules for whatever reason. In that particular instance, allowing their SolarWinds server access out to any IP address out on the internet. Now, they might have had it locked down to HTTP or HTTPS, but really, the question is, why would you allow your SolarWinds server out to anywhere on the internet? And I mean, that's not just a question for a SolarWinds server. That's in general. You need to kind of have a hierarchy or a high view looking over your organization, all of the different servers and services and applications and devices, and really be looking granularly at which devices need access to what. So like I said, the STIG here doesn't really dive too much into that. So I want to move over into a few different blog posts that I've written on network access controls. And we can kind of look at a few different ways that we can be a bit more strategic in implementing some controls that can help protect our organizations. So if we go, let's see, I have Safari up over here, and let me move over into this. And this is a blog article that I wrote talking about network access controls. I'm going to put links for both of these articles into the notes in the description in the video, so you can go and poke around in these and see a little bit more in depth what we're chatting about. This one in particular is kind of just talk about network access controls in general. We aren't going to go into how you actually write these and how it goes back and forth. That's a little bit outside of the scope of what we're talking about from a strategic perspective, but you can go and look this information up if you're unsure of how access controls actually work. We also talked about different types of how you write them on different types of vendors, Cisco, Juniper, Linux, stuff like that. What I want to hit on here is kind of a few different strategies of where we can go about implementing these. And then I'm going to show you a nice little diagram I put together that kind of breaks this out in a very simple way. So the first type of network access controls that can be very beneficial is your perimeter or premise-based ACLs. And you're probably going to put this out on whatever type of routers or switches you have outside of your organization, outside of your firewall. And pretty much what you want to do is knock down as much unwanted and unnecessary traffic at that point so you don't put additional load on your firewall. So what types of things might you block out there? Well, you might block all types of remote access protocols that you know should not be going inbound into your environment. Maybe at that point you block all incoming SSH connections, all incoming RDP connections. Maybe you're going to block certain types of IP space. So you can use something that's called like a Bogan's list, which has different types of IP space that shouldn't actually be routed on the internet. It might be reserved for different things, but could be used as different types of attack vectors. So you might implement something like that. You might know that you only have certain types of protocols that should be coming inbound from the internet. So maybe you're going to put another rule that allows only those protocols and blocks everything else. You might have a rule that only allows IP addresses or traffic to IP addresses that are your public IP addresses. Inversely, you can have a rule that only allows outbound traffic from your public IP space. So maybe it will block anything that's private IP addresses, or if there's some other type of misconfiguration. So that's kind of a very easy, kind of very static type of configuration that once you put that out there, for the most part, that doesn't change too much, and it's kind of just a good security practice. The next type of ACLs or network access controls that are really, really important are interzone ACLs. And I'm going to use the term zone just because it's kind of synonymous with security zones, or you could say VLANs, or you could say subnets. However you go about breaking up the different types of services and subnets that you have within your organization. So interzone traffic is going to be anything that might be from one VLAN to another within your organization, or it could be what you consider any type of traffic that's internal going external out to the internet, or vice versa, internet coming internal into your organization. What this means is you're probably implementing some type of firewall device at the edge of your environment that's going to be scanning all this traffic. Depending on how large your organization is, you might actually have multiple firewalls at different types of connection points within your organization and have different types of security zones configured off of those. And at that point, you would still be putting in different types of interzone ACLs. When it comes to determining, how you want to actually break up your subnets and how you want to break up your VLANs into different types of zones, that really depends on the organization. For me personally, I like to get as granular as I can when it comes to that. And I'll give you kind of some examples of that. If we go over to another blog post that I did talking about network segmentation and isolation, these are just some sample examples of different types of security zones or subnets that I might want to do. So if we're looking kind of like at our internal servers in our environment, I definitely would put my domain controllers in their own security zone. Database servers would be in their own security zone. Security tools would be in their own zone. Email servers, network device management interfaces, web proxies, keep those all separate and have specific rules for everything going in and out of that. Same thing with end devices, right? You don't want your workstations in the same security zone or subnet as your servers. That is going to be lead to a lot of issues, a lot of security issues there. Again, your workstations, you don't want them in the same VLAN as your printers, or in the same VLAN as your VoIP phones, or as your VTCs. You can kind of see that you just took some very, very simple things that we would normally have within a medium-sized organization, and kind of just was very specific and particular in the way that we broke those out. So that's kind of, the gist of what I'm talking about when we're talking about intra-zone network access controls. Is you want to ensure that the domain controllers are only talking to, the workstations over the correct ports and vice versa. You don't want to have just everything able to communicate with each other over any ports. That's how you're going to end up getting into some very, very sticky bad situations from a security perspective. When you are doing that, I guess I should mention this as well, it does take a lot of work. And it's normally easier to do at the beginning of building a network than after the fact, because there's a lot of documentation and testing to make sure that you have the right policies in place and you aren't blocking customer traffic. So kind of, an easier way to do that would be implementing ACLs and maybe turning on some logging with that to see what it is that's matching rules versus stuff that's not matching rules, and kind of working through it that way if you're trying to limit the impact to your organization's mission when you start to try to clamp down and secure your network access controls. Here's kind of just like a very, very simple sample that I did as far as how you would go about documenting data flows. So for instance here, we're talking about the email VLAN, talking to the domain controller VLAN. So we're talking about which servers, which protocols we're going to use, the ports associated with those, and kind of a justification for why we want that rule in place. Again, this is a little bit of an arduous task, but your environment will be a lot more secure if you actually go through these processes to implement these and continue to manage this in an active way. Now, obviously, this becomes a lot more difficult when you're in an extremely large organization. At that point, you're going to want to start getting some automation in place to be able to help you maintain and monitor these types of data flows. So we talked about premise-based ACLs. We talked about interzone ACLs. The next one is intrazone ACLs. Now, this is the one that out of these three that I see organizations do the least. And this is going to be some type of access controls that you're going to be implementing within a subnet or within a VLAN to limit and control what's called east to west communication. And this can be where things get really, really, really sticky in the event that a host gets popped, goes download something bad, ends up getting some type of malicious software, ends up being compromised, and then is able to communicate with everything else that's within the subnet or VLAN that it resides in. So having some type of ACLs that actually are attached to the individual VLAN via something called a VACL or VLAN ACL is a great way to control the traffic that is within a particular subnet. Now, normally when I do these and implement them, architect a solution using VACLs or an intrazone ACLs, what I do is I'm only focused on writing an ACL to permit and deny traffic within that subnet. So I make rules specifically for that. Anything else below those rules, which is going to be traffic that's going to be coming from other VLANs or other subnets, I permit all of that. And the reason I permit all of that is because I'm relying on the interzone ACLs that are being done up at the firewall layer or at the other security device where there's actually routing happening between the different security zones. And the last option, well, let me make one more caveat with this because it's worth mentioning, especially if you're implementing these VLAN ACLs in an environment where you're using some type of virtualization. You do get to the point where if you do have hosts that are within the same VLAN that are on the same, let's say ESX host, for instance, since that traffic for communicating between them won't actually be going up to the next level of switches, your interzone ACLs aren't going to be effective at that point. So you can either do ACLs on your vSwitch, or you can do something which is going to be the last one that we're talking about, which is host-based ACL. So this is going to be something like either IP tables, like on Linux hosts, or if it's a physical appliance or something like that, you can have different types of access controls within the application. Or a Windows host, you could use Window Firewall, or any other type of firewall software that you would have on a Windows host. For me, normally when I do this, because this can also be kind of arduous to manage, I normally like to only implement these in an inbound manner. So I don't care about whatever the host is sending outbound, because I know that everything else within the environment also has host-based ACLs that are protecting against inbound traffic. And then I know that it's also going through the intrazone ACLs and the interzone ACLs. So it's kind of a little bit like defense in depth, and I'm trying to be strategic in the amount of effort that I'm putting into each of these things. Again, that can be a little bit challenging to manage if you aren't doing it in some type of automated manner. So, if you're using Linux servers, then you can push out configurations for your IP tables via satellite. Or like I mentioned, if you have some type of third-party software that does host-based firewalls, then you can obviously manage that at a central point, and it makes it quite a bit easier to make sure that's implemented across the board. Now here's a cute little picture here that kind of breaks down a super, super simple environment and kind of lays out the different types of access controls that we were talking about at the points that we would want to do them. So again, out here on our premise devices, which are connected directly to our internet circuits, that's going to be our first layer where we're going to knock down a whole bunch of spam traffic, the bogans list, unnecessary protocols, things like that. Then at our firewall or other type of security device where we're going to be doing routing between different VLANs and subnets, that's going to be where we're going to have our different security zones, and we're going to have our rules to allow only the necessary and approved traffic between the different subnets. Then as we move down a little bit further, down at the layer 2 level, we're going to have our intra-VLAN or intrazone ACLs. And lastly, once we get to at the particular host level, then we're going to have our host-based firewalls, where, like I said, I like to do it to only be protecting against inbound communication. So yeah, that is kind of my spiel on network access control. It's really important. It's really something that a lot of organizations, I feel, don't necessarily do it very well or in a robust way. It's very easy to kind of just open everything up and just let everything fly all over the place like the Wild West. And it is a pain in the ass to go back and try and lock all that stuff down after the fact. So if you have the opportunity to try to implement some network security best practices when you're in an environment or building out a network, then take that opportunity to document the data flows, find out the right ports and protocols, and put together, the right types of network access control lists that will help secure your environment. Again, it isn't gonna, be the be-all end-all for network security, but it's a very large foundational piece that a lot of places don't necessarily implement as thoroughly as they could. So, yeah, does anybody have any questions on any of this stuff? Let me see. I think that about covers everything I wanted to chat about on that. So if anybody has any comments or questions, they can throw them, down below, and we can talk about that. If not, make sure you come back tomorrow for another chat video. I think, what are we going to be talking about tomorrow? Managing and monitoring interconnections between your environment, the cloud, and other organizations, I think is the topic for tomorrow. So I appreciate everybody coming in. If you haven't smashed that like button to the point where you've almost broken your keyboard, then you're doing me a disservice. So please do that. Also, if this is your first time checking out this series or my channel in general, yeah, I appreciate it if you subscribe to the channel. That's always a great thing too. Oh, got a question coming in. Let's see. Let's add this to the broadcast. Any automation software you recommend to scale a network quickly and securely? So that depends on a few different things. So when you're talking about scaling it quickly and securely, are you just talking about implementing security configuration? So you have like a baseline configuration that you want to implement across all your network devices. If that's the case, then you can use something like Ansible I think you can use Puppet too. Juniper, you can use Chef. Juniper has some security director software that you can use to implement stuff across their security devices. SolarWinds NCM is awesome. That's actually one of the reasons why I haven't gotten too much into other automation tools, is because I've been using SolarWinds Network Configuration Manager for so long. Super easy because you actually don't need to write anything in Python, or you don't need to write anything in JSON or really any other type of scripting language. You write it in the native configuration language that you would use for the device. It creates, pretty much a batch job and goes out and implements all the configuration changes across any of the particular devices that you set up with that particular job. So I like that quite a bit, although obviously SolarWinds is in some hot water at the moment. It's still a pretty good tool, and it makes the learning curve as far as implementing configurations across a large organization very, very easy. Let's see, we got another question come in. Listening in the background. Hey, how's it going? Yeah, appreciate you checking in and listening or watching. And like I said, all the stuff that I covered as far as in the blog posts and the diagrams and all that stuff, that will all be in the description of the video. So if you didn't get to actually see that while you were listening to it, obviously you can go back and watch the video, but then also the links for those articles will be there as well. And any other questions or comments? This one actually went a little bit longer than I normally. I'd try to keep these things to like 10 minutes, but it is one of my favorite topics to talk about and something that I try to share with folks as much as I can. So, yeah, if that is it, then we will wrap this up. And hopefully I see all of you tomorrow in the video then. So, all right, everybody have a good night. Bye.